In about 5 billion years, Earth's story ends. The cosmos has hardwired a physical expiration date into our planet. Our sun is currently in a stable main sequence phase, but eventually it will exhaust its fuel, expanding outward to transform into a massive red giant that completely engulfs the orbits of Mercury and Venus. Even if Earth itself survives the physical expansion, the sheer heat and proximity will boil our oceans into space and completely strip away the atmosphere. We know exactly how this physical planet will perish. The real unknown is whether humanity will be around to witness that final sunrise. That distant 5 billion year deadline has zero impact on us today. What matters is the gauntlet of immediate catastrophic threats standing between us and that fiery finish line. The most pressing dangers are the ones we manufacture ourselves, operating right now on a human timescale. This chart shows rising greenhouse gas emissions. As this line pushes global temperatures upward, it approaches a critical tipping point. Once crossed, the math becomes irreversible. Melting ice caps force sea levels up to drown coastal cities, while escalating heat waves collapse entire ecosystems. At the same time, we are rapidly developing artificial intelligence. And advanced AI could automate solutions to our greatest problems, or it could begin making decisions at speeds we can no longer oversee. Because we actively accelerate these emissions and technologies every single day, these human-made hazards are the most urgent variables in the extinction equation. But even if we perfectly manage our own behavior, we still have to survive the planet itself. Earth is inherently hazardous. A 10-kilometer rock releases the energy of billions of nuclear weapons. A direct ocean strike sends colossal tsunamis outward and triggers global fires. The Cretaceous-Paleogene extinction event proves this. A single impact threw enough dust into the atmosphere to block the sun, creating a nuclear winter that starved out the dominant species on the planet. Beneath the surface, massive geothermal pressure generates a different kind of hazard, powering supervolcanic systems like the Yellowstone caldera. An eruption there could blanket continents in ash and drop global temperatures for years. Existing here means playing a continuous game of probability, where the risk of a total wipeout never hits zero. Zooming out further, we encounter the physical certainties of the universe that no amount of earthbound engineering can defeat. Even if humanity outlives the red giant phase, our star will eventually blow off its outer layers, leaving behind a dying white dwarf. At that point, whatever remains of Earth will be nothing more than a frozen, lifeless rock drifting through the dark. Expand the scale even further, and the universe itself faces an expiration date, whether everything slowly cools into a silent heat death, or space itself expands until it tears apart in a big rip. The physics are absolute. On a long enough timeline, staying bound to a single planet guarantees a 100% chance of human extinction. To survive the long-term physics of our solar system, humanity may eventually have to look beyond our homeworld, treating Earth as a launch point rather than a permanent destination. Becoming a spacefaring civilization is a complex technological challenge, and the most viable first step in our neighborhood is Mars. Agencies and private aerospace companies are already building the heavy lift vehicles required to move millions of tons of cargo and eventually people off this planet. A cross-section like this shows the brutal reality of an unterraformed Mars. Colonists require heavy shielding to deflect high levels of cosmic radiation, intense heating systems to fight the extreme cold, and artificial atmospheres just to breathe. To escape, we will have to master the exact same fields: advanced AI to run the habitats, and massive climate engineering to terraform the surface, that currently threaten our stability back home. Right now, we are pinned between the violent, unpredictable spasms of our own planet and the slow, inevitable decay of the stars. The immediate question is whether our internal conflicts and unchecked technological progress will trigger our end before nature gets the chance. Unlike the dinosaurs buried in our museums, our fate is not dictated entirely by the sky. We have the ability to track near-Earth objects, engineer climate solutions, and actively shape our environment. The destruction of the planet is a physical certainty, but our extinction is not. We can choose to step into the stars and outlive the world that created us.